To look at the operation of the GUI, I'm simply going to switch over to the application processing, which I reminded you was the GUI is written in. And those of you who've perhaps used an Arduino before may say this looks familiar, apart from the black color, usually green with Arduino, because this is actually the same interface which is used for the Arduino IDE, which is written in processing. The script that we're going to use, which is just effectively a text file, is in here, and we can see that it looks pretty fierce and possibly to start to look with, but in fact it's just very, very simple commands. There's a lot of commands to draw rectangles and the like, and we'll see best how to understand it if we actually start it running, which we can do from the GUI by clicking on the Go button there, and that generates the interface. It's slightly wider than the one we used previously because that wasn't showing the entire title. It looked a bit messy, so I made it a bit wider than it was before, but I didn't want to make it too big so that it doesn't take up too much room on the screen. Now, in order to send signals to Sonic Pi, we use what's known as the Open Sound Control Protocol, or OSC protocol, which Sonic Pi uses quite heavily internally to communicate between the various parts of the GUI, the Ruby server, and the SC synth from Super Collider. And in order to do that, we need to import a library called OSCP5 into this sketch, as it's called. And we do that from the sketch menu by selecting import library, because this is not one of the standard libraries within processing. You can see that I've done it before. I've actually been searching for OSC up there from the big list of libraries that are available, and you can see also the green tick showing that it's already been installed for this particular application, but that's how you do it. The other library there, the NetP5 library, is there as standard. We don't need to explicitly install it. I'm not going to go through in too much detail how this works because there is an accompanying article going to be published on my blog about the use of this start bar selector, and you can browse over it there in more detail. Suffice it to say that we need to have a few variables set up, as in any program. The net address for Sonic Pi is going to be the address where it's located, and since we're running it on the local machine, you can see down here that it's actually set to be the address 127001, which is your local machine, and the port number 4559 is the port in which Sonic Pi is listening for external OSC messages, which can be used to provide synchronizing information to it. We also have variables for the mouse position MX and MY, and two important variables, BS, which is going to hold the bar at which we want to start from, and TR. I called it TR because I was dealing with the transport mechanism of Logic Pro when I first wrote this, and that's simply going to be the play-stop control. It's initially set to 0 here, but it's set to 1 if we want to play and -1 if we want to stop. So we have a setup section here, and that sets up a background color, this gray color on the screen. It's going to refresh, that's the redraw rate of this window 60 times a second. It sets its size. It opens up a UDP socket from which we can talk to Sonic Pi. It has a fill address of white, which it puts into the rectangles which are created here for the sensitive areas which will respond to mouse clicks, apart from the play one, which is filled with red, you can see down here. And the rectangle for stop is initially redrawn with a color which is the same as the background color, fill 204, so that it appears grey, because we don't want to start stopping before we started playing. Then we have to set up the font that we're going to use for the captions, and then we print the captions on the screen, and the starting value of the BS variable, which is the one which is printed in the middle here. This next little routine is the routine to send OSC data. It's going to send two integral values, the TR variable and the BS variable. And then we get the main loop. This is going to read and store the mouse position. If the mouse is pressed, it then in turn interrogates the mouse position and compares it to the positions of these rectangles. And if it's inside one of them, it'll carry out the operation which is specified. So for the BS minus rectangle down the bottom here, if that is clicked, it's going to make BS minus equal to 1. It's going to subtract 1 from the value of BS. Obviously, if it's less than 1, which cannot happen, it sets it back equal to 1. It fills the rectangle with green as we type it, and you can see if I do that, it goes green there. It's not getting smaller because it's already 1, but if I clicked on the BS plus 1, that would go on getting bigger each time we went round this loop. This loop doesn't do 60 times a second, it's slowed down at the bottom with a loop delay of 50 milliseconds so that we can actually still manage to set this going up in ones if we click very rapidly there, or down in ones, and it's a compromise between going up quite fast if we want to move a long way and still being able to move up and down by 1 when we need to. And clicking in the BS1 rectangle there will set it down here back equal to 1. And so that's more or less all it is. If we take the two which are slightly different, the play rectangle, that will set the value of TR appropriate. So to play, it sets it to 1, and it then sends, using the OSC data command, the current value of TR, which is 1, and the current value of the bar start variable. The flag variables here are simply put there so that if we hold down on play, we only send one message, and next time it comes around the loop and says we're still pressing it, it doesn't send another one until we've released the pressing the play button, and the same with the stop button there, which simply sets TR to -1 before it sends that. And the other things these do is they change which rectangle is red, whether it's the play one or the stop one. You can see that switching over as we click on them there and there. See it switching over. Okay. Now, we also want to have another program running. It's in fact been running already from previous work I was doing, but if we just stop that from running and switch now to the third entry here, this is the program that was actually running there and is dealing with the other side of the coin. How does Sonic Pi actually pick up these messages? As I say, it listens on port 4559, and it simply uses the standard sync command in Sonic Pi, except we use it slightly different because you want to get some of the information that's sent rather than just the name of the sync, which is /transport. That's the name of the OSC message that we were sending. So we actually set S equal to sync and then the name of the brackets there. And this is where you get the slight difference in code depending on whether you're using 2.11 or 2.11.1. And here perhaps Sam Aaron would like me to say that this is an undocumented command within Sonic Pi, and to that extent is experimental. And although it's obviously fixed in 2.11.1 and there and 2.11, it may well change in different versions, but as long as you're using the standard release versions at the moment, then it should be okay. It still currently works in version 2.12, which is the development version at the moment. And so I simply have a little routine up here which lets me split up the parts of the version number which is sent here by the built-in command version in Sonic Pi. If you're using 2.11.1, it'll say v2.11.1. If you're using version 2.11, it'll say v2.11. If you're using v2.12 point something, it'll say v2.12 point whatever. And so at the moment I'm setting it so that if it's version 2.11.1 or higher, then it'll use this mechanism to get the two pieces of information that we passed in, the value of TR and the value of BS. These are simply passed in into the array that we've set equal to the sync command, and the first value S0 will be the first integer we added, which is tr, and the second one, which is bs. If you're using the earlier version, you have to use this mechanism to get it out, but otherwise it's exactly the same. And so we've got a loop here. It goes from there to there endlessly. So when we run this program, it is continuously waiting for the sync command to come. When the sync command comes, this one will wait until tr is equal to 1, and then it will print this message. This one will wait until tr is equal to -1, and it will then print the other message that down here. So let's see that operating. There, we picked up. Let's just move this back a bit. We can get on the right place. Oh, it's as far as we'll go. Play stop tr variable is 1, bs bar start variable is 1. If we make the click on stop, it changes the play stop tr variable to -1. If we set the bar start up to 13 to play again, then that changes to 13. If we set it down to 6, press stop, that goes down to 6. It doesn't make any difference there, it's not used because Sonic Pi would have stopped playing, but next time we press play, it would start at bar 6 again. So this type of code is added at the beginning of the programs that we want to control. And we now need to move back to Frere Jacques and see how we add in the other 3 parts to make our 4-part round, and how we can also then add the extra code at the beginning, which lets us synchronize to the start bar selector, and also how we can actually use it to start at any particular bar within the piece. So that will be the next part.